Here we are in mission control, and here's our fancy panel here. Yep. Yeah, this here is my homemade charge controller diversion center that will switch a wind turbine, 3-phase, into a bridge rectifier, and then down into the charging lines. Over here is a 24 volt 12 amp marine charger. This is just in case there's a power outage, my batteries start going low, I can plug this into a generator and run my lighting, which is plugged into the UPS. The UPS runs on 24 volts, it's 950 watts, and it works very good. It's pure sine wave. And up here is my 15 amp breaker box that I have here, and this here controls the lights. What I did is I went into the panel. Don't do this at home. Your neighbors will get worried. They think you're going to burn them down. So don't do this, kiddies. Don't go into the panel. Don't pull off all your neutrals for your lighting and all the hots for your lighting and connect them up to a cable and wire them into a little sub box there with a 15 amp fuse. See, my total load is less than 15 amps. There's 2 fuses available in there, so if I need to split it off and run 2 branches and add another UPS down below, I can do that if I want. This runs most of my lighting. It'll give me about 3 hours with a few lights during a power outage before I have to start up a generator, add extra power. This here little gadget is a blocking diode, and what that's for is to block the back charging from the UPS. What happens is the back charging from the UPS will shut down solar controllers and stuff that come in at a lower voltage level, telling them that the battery's full. So if you block that, then it'll allow charging from wind, solar, or whatever you want to combine, which is what this thing will do. This has the provision to add a grid tie inverter when the load gets above a certain level, which hasn't really been established yet because I don't have a grid tie inverter and I have that feature disabled at this time. Might as well come in and take a look at that. That's just a standard fuse box there with 2 fuses. As you can see, I'm only using one. That's wired into the panel. All it's doing is holding it in the panel. In the grommet, it's actually wired up to these lines that are not connected at all to the panel except for the grounds. Down here is a 20 amp line. This is what feeds the power inverter and whatever else I want to run. This is 12 gauge 20 amp receptacle down there. It's split receptacle, so I got 20 amps per side, so I got plenty of power available from AC. So then here we got our switch, we got the spin, that's nothing, no load, and then brake. If it's windy and I want to shut the thing down or work on it, I can do that. With it on load, it just goes into the bridge rectifier, comes down here, joins in with my charging. So then what we do is we try to get this. I don't like this thing. Oh, there we go. So now we're running on battery. Now we're not running a lot, so there's not a lot of draw. So what we'll do now is plug in the marine charger. Okay, so marine charger's on, and it's giving us almost 7 amps. It's cut down now because it's no longer in boost mode. This has different modes. Right now it's in absorption mode, which gives a higher voltage. so it automatically draws less current. As soon as the UPS starts to draw power, like if I was to go and load it down, because like right now there's nothing on the load side right here. So this is a 950 watt APC, nice American made, or at least American designed. This was probably made in America. The new ones may be designed in America and built in China. Who knows? I don't know. I know their new ones are a slightly different style. These guys you can find on eBay. Excess UPS. They sell reconditioned ones with brand new batteries in them. I pull the batteries out and use them on other ones and then wire them up like I did here. I got my main line coming in from my battery bank, which is number 4 battery cable. That was the cheapest way to go. They were on sale for I think $12.99 in the summertime, so I bought 3 sets of them. They were 12 feet long. And it just goes along here and then down into that conduit, which goes into the battery box. Now these lines coming in here, the speaker cable is the 3-phase AC input coming from the wind turbine. This is 12 gauge speaker wire, what I happen to have on hand. I wasn't about to go out and spend a fortune on number 10 solar wire, not until I knew it was going to do something. And I figured, besides, if I have it running through a building and I have it poly piped where it's outside, it's not going to be exposed to the elements. It's 12 gauge, it's a little bit heavier than what's on the wind turbine, so it'll work fine. This fancy thing here is nothing much. It's just a fuse block, just what I happen to have on hand, and that's just in case something was to short there. This isn't starting to heat up yet, but this will get nice. I can smell it inside. There's a nice heavy wire that's wrapped around a ferrite core that gets nice and smoking hot. Oh yeah, she likes to warm up in there, but you know, that's pretty good. It's not bad. Over here was just a test rig, just testing load. These are approximately 7 to 8 amps a piece, 200 watts, 24 volt immersion heaters. So if I want to measure load with a meter to see that the power supplies are outputting the proper amperage, I can just load them down and check.